Good morning, everyone. So I wanted to do a supplement video in relation to what you already have online, which is pertaining to ionic compounds. So I want to just first off say that you should be watching those lecture videos, but then this one's going to be a follow-up to what you've already learned in terms of ionic compounds. Now, what I want to do is just sort of do a cliff notes of what you've already been taught, and that is just making sure you understand that there are three types of compounds in terms of ionic. So the first one again is that binary compound, which is dealing with two elements bonded together, and those two elements are a metal and a non-metal from the main group elements. All right. So that's the first one. The second one was dealing with the polyatomic ions, and this pertains to the memorized polyatomic ions found in the PowerPoint and the things I should know document. All right. And again, these are just cliff notes here, of course, right? Then you have the transition metals, which involve the so when naming, you will use Roman numerals to identify the oxidation state, and I'm going to put this in quotations, charge of the transition metal. Okay. Now, with that being what we've been taught, so what I want to do is I want to apply some of the rules for you. So now we can do many different examples. All right. Now I will suggest that you do work that worksheet that has 80 questions on it. That problem set is pretty conclusive in terms of what you need to do and be able to practice. The worksheets that I provide you for the problem sessions, those are also something that you should pay attention to. And so again, this video is sort of just to summarize what you've been taught already. It's a video to give you a little bit more information in terms of examples that you may come across. So again, when we work with binary compounds, we have to pay attention to just naming the metal by its elemental name, and then the non-metal, you change the ending to IDE. All right. So an example being, and this is the most common example, would be sodium chloride, all right, which has the formula of NaCl. All right. Another example would be magnesium oxide, which would have the formula of MgO. So keep in mind that when you are working these, you make sure you go back and you look at the mountain. The mountain helps you to figure out the charges. 1A is plus 1, 2A is plus 2, 3A is plus 3, 4A is plus minus 4, 5A is minus 3, 6A is minus 2, and 7A is minus 1. So you go 1, 2, 3, 4, 3, 2, 1. So it's like an arpeggio. And so, again, this is something that you can utilize throughout this course, and especially right now as you're working and practicing those, writing the formulas from the names. So magnesium is in group 2A, so it's plus 2. Oxygen is in group 6A, which is minus 2. And what happens here is the plus 2 and the minus 2 cancels out, and it leaves you with a formula of MgO. Now, if I were to take, let's say, magnesium and phosphorus, well, that's no longer going to be the same scenario. So magnesium still is +2, but the phosphorus is -3. And so a common number between these two are 6. It's 6. So now what we are going to do now is I don't like to use a crisscross rule, because if you ever were taught the crisscross, just forget it, ignore it. What we're going to do is you're going to find a common number between the two, and you're going to divide that out. So dividing out 6 divided by 2 gives me 3, and then 6 divided by 3 gives me 2, and that's where you get your formula, Mg3P2. Now the name of this would be magnesium phosphide. All right, so magnesium phosphide. Now we can carry this on. So let's say if we have a compound, let's say barium nitride. All right, so barium nitride is going to be Ba. All right, Ba has a +2 charge, and the nitride is in with a -3 charge. So again, the common number between those is 6. All right, and then as we divide out, we're going to have 3 bariums and 2 nitrogens. All right, so that would be the formula for barium nitride. All right, now if I take calcium fluoride, all right, so calcium is +2, and then fluoride is -1. So, well, the only thing that you can do here is have more fluorines to balance out that calcium. So you're going to have a formula of CaF2. Now, -2 would be what cancels out with the +2. 2 divided by 1 gives me 2, so that's why it's CaF2. All right. So we could continue this, but you know the pattern is still true. You have to pay attention to the charges of the main group elements, and then you have to make sure that you balance those charges with the metal and the non-metal in terms of writing the formula. All right, so in terms of the polyatomic ions, so remember that there are specific ones that I ask you to memorize, and it's especially for the first exam, and this is something that you're going to need to make sure you do over the next few days. All right, it's just something that I expect you to do and require you to do. So if you don't do this and you come in on the first exam, you will fall flat on your face. So just make sure that it's something you start working on now if you haven't started working on it. So everything that is highlighted right now is going to be fair game on the first exam. And so now as you start to work with the memorized names and the polyatomic ions formula, you also need to make sure you pay attention to the charges as well. All right. So now again, all the other ones that you see here, they're not necessarily something that you're going to use often, if ever, but they are still something that you need to make sure you take note of. All right. But again, for the first exam, everything is highlighted in the yellow color is something that you need to make sure you have. So now as we talk about the writing formulas and or naming the compounds, we have to make sure we pay attention to the subtle details that we have present. And then again, those details are based around the charges of both the metal and the polyatomic ion. So like for example, the first one here, barium hydroxide. So barium has a charge of +2, and the hydroxide has a charge of -1. So it's going to require 2 hydroxides to balance that 1 barium. And so what we end up doing is we put parentheses around the hydroxide to show that there are more than 1 hydroxide present. In this particular example, you have 2 hydroxides that are present. All right. Now, sometimes, and this is another example here, you have a compound like sodium cyanide. All right. Now, sodium cyanide, you have Na, which is +1, and then you have the cyanide, which is Cn with a -1 charge. Now, the nice thing about this is that you have both +1 and -1, so they cancel out, and you have a very clean formula of NaCN. All right. So again, the same thing goes for this as what we did in the binary. You have to pay attention to the charges, and then you need to make sure you cross-check the charges to figure out how many of each element should be present, or polyatomic ions. So now, a good example would be calcium phosphate, where calcium is +2, the phosphate is a -3 charge. So a common number between these two would be 6. All right, and then you just divide it out. So 6 divided by 2 gives me 3 calciums, and then 6 divided by 3 gives me 2 phosphates. So this would be the formula for calcium phosphate. All right. So you can also go back through, and let's say, for example, that I have a formula of AgNO3, and I want to name this. Well, naming it's just as easy as writing the formula. The metal is what it is, it's silver, and then the polyatomic ion is nitrate. All right, so the name of that would be silver nitrate. So again, it all goes back to making sure that you have memorized these polyatomic ions and their respective formulas and charges. So that's what we're going to do for. I'm going to stop there for this one. I'm going to have another supplement video posted shortly in reference to the transition metals and how we go about naming them and writing the formulas, etc. All right, so thanks for watching, guys.